So here we have our water VFDs, which basically allow the water to be controlled to take it up to the 11th floor, and actually 1 through 11. The city's incoming water is probably at about 45, 50 psi, depending on city conditions. We have 2 pumps down below. These are alternating pumps. You can see the one on the right in the picture is newer, and the one on the left is a little bit older, but both fairly new, good pumps. I also have a rebuilt one in the other side, completely rebuilt, ready to go, because if we have a failure, we got what we need. So if we walk over this side, you can hear the pumps basically circulating at this point. And what we have is we have a city water gauge, which is showing us 40 psi. That's our incoming water before it gets to the pumps. And there we go at 120, fluctuates because right now we're under usage from the city. And that's what you need to get it up to the 11th floor. Basically that pressure will take it up to each individual floor. Each individual floor has a PRV, pressure reducing valve. And what that does is it reduces the pressure going onto each floor at about 80 psi. 75 to 80 depending on the setting, but that's right around where it needs to be. Here's the city incoming water. And that's actually the meter, so it's not going to tell us much other than the pressure of what we needed, which I showed you on the other gauge. So that's a radio activated meter. Water comes in through the city and comes in through the main pipes and gets boosted through the pumps, which are both turned on. As you see the valve takes it through this line on up into the entire building. I have a drain valve here if necessary to bleed the pipe if we ever need to do any kind of a major overhaul on this. And that's what you got. Over here we have a backflow preventer. That's your city water incoming area right here. And that's a backflow preventer, which in reality what that does is it prevents water to go back into, let's say, the fire truck who's using our water to put out a fire. They don't want, and we have chemicals in a sink somewhere that has a tube hooked up to it. It won't take those chemicals and backfeed them into the pipe system and cause some damage on the other side. So again, here we go, and here's city pressure coming in. Again, everything fluctuates slightly. It's never going to be consistent. It all depends on volume, pressure, static, basically vibration of water running through the pipes. That'll slow it down, how far it has to go in the pipe. And that gives you a basic idea of the water system and how it works. Again, this pipe will take it up to and through the entire building. You can see if you follow it through all the way, that goes to the central shaft system, which is right around the elevators, and up through the central part of the building, and then branches off in half-inch pipe after it goes through a PRV, a pressure reducing valve. These all have set points of about 75, 80 degrees, 80 psi in a high-rise in Philadelphia area. That will basically allow everybody in all the units on that floor to receive pressure during peak times specifically. It will probably hold steadfast around the 75, 80 psi on average during off-peak times. But on peak times, if you have 4 or 5 people taking a shower at the same time, running water, running dishwashers, running washing machines, we definitely don't want them to drop down to 40, below 40. That's not a good thing. You want to keep customers happy, residents happy. They don't want water trickling out of their pipes and their toilet taking forever to refill, those kind of things. So they're the kind of things you run into in a high rise. That is your water system, domestic water.